Welcome back everyone, I'm Zell, and today we are moving slightly out of the EDC realm and we're going to talk about 3D printing. More specifically, we're going to talk about double wide vase mode. Joel Telling did a video on this quite some time back. I was intrigued by it and started experimenting some. And we're going to do some destructive testing here in just a couple minutes. So what is double wide vase mode? Basically, we're going to use your standard nozzle, whether you've got a 0.4 or 0.5 in your machine or whatever other size, and where on a 0.4 nozzle your standard line width is somewhere between 0.42 and 0.45, depending on your machine and your slicer and how you've got things set up. But most of the time on a stock machine, it's somewhere between 0.42 and 0.48 with stock slicer settings. And we're going to take that and we're going to make that line nearly 0.9, somewhere around 0.8 at least. And what does that do for vase mode? Well, vase mode out of a 0.4 nozzle, you get like this. This should be a very tough print. It's PETG, so it's it's a little flexy and should be tough, but if we put the calipers on it, it is, you guys just have to trust me on this one, it was set at 0.42 and that's about what I'm getting, 0.42, so it's less than half a millimeter thick, and I can tell you it's not very tough. I already broke it a little bit just getting it off the build plate. And this is another PETG print, both of them atomic PETG. This is a silver, that's a kind of a starry night blue, I believe, but this one is showing up about 0.8 all the way around, maybe a little bit less there, a little more there. Whenever you do this vase mode, double wide vase mode, you don't always get exactly, because you're essentially pushing as much filament out of that nozzle as you possibly can. So how do we do this? We'll get into the specifics here in a minute, but here are the basics, and I'm actually going to go through the slicers with you, all three of the major slicers. Basically, you double your line width, your wine width. Anyhow, and you slow down the print. And we can talk about slowing down. You're not really slowing down the print because you're doing an outer wall perimeter. So you're really going to be printing at your same outer wall speed that you normally print. And if you have problems, you can bump up the temperature or slow down the print. And that is it in a nutshell. And you do it in spiralized vase mode, of course. We'll go through all that here in just a minute. Now, let's do some destructive testing. All right, guys, let's get a look at this print real quick. This is a Todd Knife and Tool end mill vase or vase, however you'd like to say it. And it's something I made up really to test some tall prints. These aren't terribly tall because I don't want to take forever to print them. But this is 0.4. Your standard extrusion width for vase mode. And there you go, that's what it looks like if I can keep it in the frame there. And this is the same print, but it's done in double wide vase mode. And pretty significant difference. So let's get to breaking prints. So first off, let's try, let me get myself in front of the camera enough to where I can do this, and let's just try doing a little bit of crushing. Nothing horrible, little crushing. Oh, makes sense. Got a line all the way across there. So let's get the other one and see if that happens with it as well. Okay, now this one isn't as flexy because it's thicker, much more robust. I heard it go just a little bit, but nothing popped loose. So now let's try going the other way. Now we know that we can probably just, actually that's stuck pretty good. Layer adhesion's really, oh, there it went. Now we have kind of a halfway Todd knife and tool junk cup maybe. But what I want to see is pulling this, never mind. Yeah. All right, so let's get the double wide vase mode one out and look at that. That broke a lot faster than I thought we were gonna break it. So here's the double wide vase mode one. Let's try it. There we go. Get enough torque there with my thumb right here where my thumb's pushing in on it. So I hope you guys can see that. But where my thumb pushed in on it, we got a break in a couple of places. But oh, come on, this is destructive testing. We got to break stuff. Come on. All right, we're gonna try crushing. There we go. Ah, I may have been wrong. This may have been a PLA print. Sorry, guys. That print's been up there for quite a while. It is. I've got a double. I see the double wide vase mode in. See, that's PLA, and that's something else we're going to talk about here real quick. Didn't mean for that to happen. I meant for that for a different video. Here is the silver one in the PETG. It is flexy. So we'll go through the same testing here. We only got one shot at this, so I goofed up, and we'll just have to see what happens. So there's all of our, I mean, look at that. All right, now let's try the other way. Okay. Yeah, that's not coming apart. I hope you guys are seeing all this because it's just not coming apart. Layer adhesion's really good. And, I mean, seriously. It's not coming apart. We made some dents in it. See, it looks a little weird right there and right there now. But it did not come apart. PETG, double wide spiralized vase mode. Now, let's talk about this real quick because this was actually, I completely flubbed this. Supposed to be for a different video. This one is in PLA. And it's double wide vase mode in PLA. But what I want you to see is how this came apart. And I'm going to implore you, if you have children or pets that tend to get into anything around your house, to your vases that are printed in vase mode or diffusers or anything else that you're printing in vase mode, print them in PETG, because look at all those little sharp areas. If you have a kid fall into this, or your dog or your cat, that's just a bunch of pokey sharp things to get into your loved one, whether it's your pet or whether it's your kid. Or you, if you fall into it. Think about that. So, yeah, that's a big mess. So throw that thing away. So, let's once again look at the PETG. This is PETG in double wide vase mode. Oh, we did get it to break. Check that out. We got it to break. But for the most part, it's tough at double wide. And then here is the beautiful part of the single wide vase mode. You fall into this, you just knock it over. It's not brittle, it's not hard, it's flexible, and less chance of you, your loved ones, your pets getting hurt. So anyhow, let's jump into the slicers and see how we did all this. All right, guys, starting with Prusa slicer. How do we do this double wide vase mode? Really easy. You go to your print settings, advanced right here, And then you go over to extrusion width. Your default extrusion width, this is for a 0.3 millimeter layer height. On the Prusa is 0.5. That is going to vary per your setting. So don't worry about the default extrusion width. What we want are perimeters. We go with 0.8 and 0.8 for perimeters and external perimeters. And to get it in spiralized vase mode, we go back under print settings, so same tab, go to layers and perimeters, and we click spiralized vase mode. It will tell you a bunch of stuff it's going to change. You tell it yes. And then you want to make sure you have, depending on what you're doing, you want to make sure you have 0 top and bottom layers. That's if you're printing like a diffuser like I showed you, or if you're printing a vase, then you're going to want to have probably 3 bottom layers. Some people go more than that. Depends on your printer and how well your bed's leveled. On the Ender 3, I usually do 3 because, gosh, guys, getting that bed perfectly leveled on that Ender 3 with all the stock parts can be a pain. The Mega S, I could do a dozen, doesn't matter. The Prusa, I could also do a dozen, doesn't matter. And we're going to do some fixes on that Ender 3. So I'm not knocking the Ender 3. The stock springs and some stuff about the Y-axis is just a bit of a problem right out of the box. So that is it in Prusa Slicer. There are other things that people are going to tell you. They're going to tell you to go to filament settings, and they're going to tell you to crank up the temperatures. That's Mega S Prusa. We're using the eSun Gray PETG. I normally don't do this. I know that if you're using really big nozzles and really fast speeds, that yes, you would want to do this, but you're not going to want to go fast. And we'll look at that too. So we can go under print settings. Temperature is under filament settings right here. Print settings and speed. Now, what I did was I took everything to 30 millimeters a second. Reality is, on the Prusa where I printed that diffuser, it would have done it at 45, 60, pretty much whatever I set it at. I just bring them back to 30 just so I don't have any layers falling off and less chance of globs. And that's what I do. You go to perimeters, small perimeters, external perimeters, set them all to 30. You're going to want your modifiers down here with your first layer speed still at 20. That way, you know, you've got a nice first layer down. And that's it for Prusa Slicer. Let's move over to Cura. Same model in Cura. And we're going to go over here. First thing you got to do is special modes. You're going to want to click spiralized outer contour. And we're in a 0.2 quality for the Ender 3 right here. So that's just what we'll use. Spiralized outer contour is vase mode. And smooth spiralized contours. That seems to work pretty well. And then from there, we want to go back up all the way to the top to quality. You got your layer height, initial layer height, line width. Now, Cura and Simplify 3D do this different. We're going to go point. Should have went 0.8 there. It did. And it is going to change everything. All the way down. Wall, line length, outer, inner, top, bottom. You could go back in here like I do in Prusa Slicer and go 0.45, I think it was, or put it back here to whatever. Nope. Anyhow, 0.8, and it will work just fine for your top and bottoms if you're doing a vase. And I do allow that to happen sometimes because the thicker layers, or thicker line width, does usually put down a nicer first layer with this machine, the Ender 3. However, I don't do it with the Prusa because the Prusa puts down a better first layer, first set of layers, first 3-4 layers using the 0.42 or 0.45. So, kind of got to learn your machine. But you can change the top and bottom line width right there. But that's it. We can go down to our materials and we can bump the temperature up if we think we need to. And bumping the temperature up allows you to print faster, and some materials are going to require it. I generally print with these Atomic, eSun, 3D Solutech, and Prussiament filaments, and they seem to feed really well kind of at the proper temperatures that you're used to putting them at. So once again, I really don't change the temperatures. However, we got to get down here to speed. This is not going to work at 50 millimeters a second. Again, the way Cura works, if we go up here and go to print speed and we put in 30, it is going to mess with everything. This is a problem. You see your wall, outer wall, inner wall speeds. We don't want those at 15 millimeters a second, because if we slice, in fact, we'll slice it right now just to show you. We go to slice this, and we got 4 hours and 30 minutes for this little bitty vase topper diffuser. Don't need that. That's crazy. So we're going to go back to the wall speed. We're going to put in 30. We're going to slice that again, see what we come up with. 2 hours, 43 minutes. That's still considerably slower than the Prusa for some reason at the same speed, because I think the Prusa did it in like 2 hours. But anyhow, if you use just changing the print speed, that's what you come up with. So let's go back here. Let's go and let's look at what we got. If we leave the print speed at 50 millimeters a second, all Cura's math puts the wall speeds at 25 millimeters a second. So instead of changing the default print speed, I'm going to go here. I'm going to put this at 30, which is going to change my other wall speeds. Just something for you to be aware of, and that leaves our top and bottom speed at 25 millimeters a second. That's good. The Ender 3 does that fine. And yeah, I know you got this print speed of 50 millimeters a second, but it's never going to reach that whenever we're doing these vase mode prints, because all we're looking at is wall speeds. So there you go on Cura. Now let's go over to Simplify 3D. And we have the same vase here. Let's edit our process settings down here in the corner. And again, a little different in this one. We're going to have to go to manual, and where we have our extrusion width, we're going to have to go to 0.8. So now we don't have control over all of those top and bottom. Even if we go to advanced, we don't get that. So that is under extruder. You go to 0.8 right here on your extrusion width, and that's pretty much it for getting you going. You do want to hit your single outline corkscrew printing mode, vase mode. Click that button. Make sure that you've got your top and bottom layers set properly, because that top layer is not going to print in most vase mode prints, and then you'll have this big glob of plastic laying around that's just going to mess your print up. So top solid layers, bottom solid layers at 0 for this particular print. Where's our speed at? Speed. This is a little more frustrating, because they don't give you everything that you want, and a lot of it is all in percentages. And I love Simplify 3Ds, but I really wish we would get a Cura-esque or a Prusa Slicer-esque ability to get to everything. So outline under speed is what we're looking at here. So we can put, it's measured in percentage. That's annoying. So really what you want to do here is run, if you're going to do 30 millimeters a second, you run that to 60 on your default printing speed, and that's going to give you 30 millimeters a second on your outline underspeed. Annoying, I know. And you shouldn't have to change anything else. I don't remember. We'll look real quick. Blah, blah, blah. Yeah, it doesn't give us all the other stuff. So that is a bit annoying, but that's how you do it in Simplify 3D. We'll click OK here, and we'll do our prepare to print, and we'll go back and look at the temperatures here in a minute. I did not look at the temperatures here, but there we have nice setup. I would put a brim around this, or on Simplify 3D, you would bring the skirt closer to it. Another anomaly of Simplify 3D. So let's go back to our process settings, look at the temperatures. And you go to primary extruder temperature, and you can bump that up if you need to. And of course, your heated bed, don't need to mess with that. And guys, that is it. That is how you do double wide vase mode in each of the different slicers. Not too hard. All you're really doing is making that extrusion width wider and then compensating for it with speed. Now you can try to compensate for it with heat and leave the speeds the same. I have not had great luck with that, especially with PETG, because you'll get blobs and ick, and it's just not fun. If you do it with PLAs, it seems to work better if you're trying to do it at higher temperatures and higher speeds, but not really for PETG, and I really like printing these in PETG because of the flexibility of the material. Anyhow, back out to the desk. Alright guys, we didn't go back out to the desk, so I thought I would show you some of this footage of some time lapses. I hope you learned something today. If you didn't understand something, if you have questions, you want to see something on a specific slicer or a specific machine, I've got an Ender 3, I've got an Anycubic Mega S similar to the Mega, and I have a Prusa i3 Mark III. And we also have a Raptor and a Chiron. The Chiron, I really don't want to do any of these type of videos on yet. I've got some issues with it. But we could do something on the Raptor or any of the other three. You guys let me know what you want to see, and we'll try to make it happen. Have a great day, everybody. Thanks for hanging out with me, and I'll see you next time. And yeah, I know, if you're watching the time lapse, it's going to look like I goofed it up real bad. Give it a few seconds, it gets better, and you definitely want to stick around. The time lapse after this one is, we'll just say it's colossal. You guys can put the end word after colossal, but you'll want to see it. Have a great day, everybody.